So greeting for the day to all. And now in the today's this presentation, I am going to make a simple program in Python for all of you. That is the breadth-first search. So it is a type of uninformed search. You have already know that breadth-first search is the uninformed search. So here, what I'm going to make first one tree with the different nodes present in that tree with the root node and children under them. Then we will make a traversing order of the breadth-first search in a Python. So it is the simplest program. It is the simplest program, very simple because it is just the first lab for you. So just start with the simplest problem. Then in the next sessions, we will come on to the different techniques, that is the informed set techniques, all the informed techniques. So today I'm going to perform the first uninformed site technique, that is the BFS for you. So in this, first of all, I will make one function, and the name of function, we can keep any name of the function. Let it be BFS short form of breadth-first search. So where we will define a function and we will be making use of a making tree, and it is in a Python. Just you all know about the Python. So I start with the defining of the function. Then one list, V is the list of listed nodes. Another is the queue. So queue is there. So that is the list we have to maintain. Then we will append. So append the visited node list with the one by the node we visited. So appending the root node to the queue first of all, because first we will be visiting the root node. Then one by one, all the nodes which are in the queue, that will be appended. So first root node has been appended to the queue. Then we will go for the all the nodes which are present in the queue one by one through the loop. So first we will pop the first element from the queue and store it to any, you can say S. Let it be store it to S. So popping of the first element is done and it is stored in a S. So we pick out the first element from the first node from the node, your queue, and we will also print what we have popped out. And that has been stored in S. Then we will go for all the make a loop for each vertex of a tree. We will check if I is in visited list or not. So for that check, we will have a if condition. So if it is not visited earlier, now it means we are now visiting. So we will append it in the list of the visited nodes. And we will append it to the queue also. So now we will form a tree. So the root node in a tree, the root node is A. And the children node, making use of dictionary, and the children node are B and C. So this means under A is the root node, and two children of A are B and C. So we are making the tree ourselves. Then we make B as a parent node and insert its children under the B. So now we make B as a parent node, and its key values will be its children. Let any two children, let it be D and E. So I'm going slow so that you can understand well. Then make C as a parent. We have to make C as a parent, and under C, let its children be there. First, make C as a parent. And children as the key values there. Let it be F. So we have to decide whether we have to put any node under D, E, and F or not. So let it be a smallest, shortest tree, very small tree. So let D and E and F be the terminal nodes. So you can expand the tree as far you want, but in this example, let it be the short example, and do not take any further level. Keep it into this level only, and put D, E, and F as the terminal node, that is without any children under them. So just see, it means D does not have any child. Similarly, we want that E will not have a child. So the key value will be empty here. Similarly, for the F, so one thing very important here, that in this program we are making the static tree. Means once we in the program itself we have created the full tree. So during the runtime we will not be making the tree during the runtime. So in the other versions, in the next session, we will also make the dynamic tree, where during the runtime, we will create a tree during the runtime. But in this program, we are just making the static tree. Now we have to decide the root. So this is the, what is this root? Just I am going to tell you. It is the point from where you want to start the traversing. The point means when we will run the program, it will be user's choice from which node he or she wants to start the traversing of a tree, and that traversing order will be according to the breadth first search. So here the root node, here the root means the starting point from which node a user wants to look into the traversing order. So this user has to enter. If you want to see or view the whole tree, then the root node should be, he must enter A. If he wants to only see what is under the B, then the root node will be B, and so on. So the choice is given to the user. So therefore, user will input the name of the node from where he wants to look the traversing order, start of the traversing order. So we have to provide the root node. Now we have to call the function, and we have to provide the start node for the root. Now we will save this program and give any name. Let me save with the name as ME1 AI .py. Desktop with ME1 AI. So now let us run this program. So we have to enter the root node. Let's enter A first of all. So it was a capital A. So here the traversion. So first it goes to root node A, then two children C and B of A. Then it moves to the B and children of C. First of all C, then children of C is F. Then it moved to B, and the children of B are E and D. So this is the traversing. So it has the setting was done with the right child first, not the left child first. So the traversing is done with the right child first, then the left child. So you can also see we will again run this program, but this time we will select the another root node. Let the root node be start from B. So it has shown the only the tree under B, that is B and its child E and D. Let's go for C. So under C there was only one child. So root node that we are passing here is C, and under C it is only F. So this is the whole concept of the breadth-first search. So I hope you understand this concept. So I again repeat. So we have made one function, defined one function with the BFS, where we have created a tree and a root node will be sent as an actual parameter when the call is made to the function as here. So we are calling, we are providing the tree and the root node which is entered by the user. We have made the static tree, that is A with the two children, then B with the two children, and C with one children, and D, E, and F are the leaf nodes. And we provide, we have to see one by one that what are the different list nodes we have already visited or traversed. Then we have to append into the V, that is the visited list. the list with the visited nodes, and we have to pop all the other nodes one by one from the queue. So this is whole program about the breadth first search. So hope you understand this program.